come back. So we are now going to work on concavity. Okay. To discuss concavity, we need second derivative. All right. Second derivative. Well, we have already computed first derivative to be this. Okay. If you remember, we went through quite a detailed discussion to find the first derivative. Now, second derivative. Okay. Here we go. This is by quotient rule. So let's be careful again. Denominator square. So you already have a square. So when you square it once more, it becomes power 4. All right. Derivative of the numerator. So this is essentially negative 3x squared. Its derivative is negative 6x. This is negative 75 whose derivative is 0. So that doesn't contribute anything. So I'm just looking at derivative of negative 3x squared, which is negative 6, denominator as it is, minus numerator as it is. So mind you, because negative 3 is there, I have placed it in parenthesis. Numerator as it is, derivative of the denominator. What is the derivative of this guy? That 2 has to come down. X squared minus 25, and then you go inside and take its derivative, 2x. So what am I using? I'm using chain rule. So this derivative is quite interesting. You not only have quotient rule, you also have chain rule here. Okay, the 2 came out, this guy power 1, and then derivative of the object inside. Now simplify upstairs. Okay, negative 6x, x squared minus 25 power 2, I've left it as it is, but this I will try to simplify. So negative and a negative became a positive. 3 times 2, 6 times 2, 12. That's a 12. And there is an x factor here, x, there. Then the factor x squared plus 25, there. Then the factor x squared minus 25, there. Denominator I have not changed at all. You notice this is 12x, this is 6x. So, but also mind you, x squared minus 25 is a factor and x squared minus 25 is a factor. Okay, so why don't I get negative 6 common, x common, one of the x squared minus 25 is common. What's left? Well, from the first term, only one power of x squared minus 25 is left because 1 was brought out, 1 remained inside. 6x is outside, negative is outside. Okay. This plus became a minus because I pulled out a negative. You see, if I were to distribute, that negative times negative would become a plus. So that plus became a minus. Because I've brought 6 out, from the 12, only 2 remained. I brought out the x, so that's gone. And I brought out the x squared minus 25 out, so it's gone. All I have is x squared plus 25 inside. Okay, this is one big factor and these are the other things. Denominator is unchanged. Now, let me see what happens here. X squared minus 25. I see x squared minus 25. There are 4 powers here and 1 power here. So I cancel that one of those and reduce this power to 3. Do you see that? One factor cancels one of the powers and gives me power of 3. Okay? So what remains upstairs? Negative 6x and this. Let me open this out inside. So that's x squared minus 25 minus 2x squared minus 50. Okay, going strong. X squared minus 2x squared minus 6x squared minus 25 minus 50 minus 75. Aha, even better. There is a negative common. Why don't I get it out? When I get the negative out, with that negative, I am positive now. 6x and all the negativity is out. I have x squared plus 75 upstairs and all of this downstairs. Okay, very good. So second derivative is this expression. Second derivative is 0 and second derivative undefined give us the required cut points. So let me set this quantity to 0 as we have seen before. Maybe I'll show it in these steps. This quantity has to be 0, right? So this quantity has to be 0. Well, why don't I write the 0 as a fraction? 0 upstairs, 1 downstairs. Okay? When I do that, I cross multiply. 1 times this guy is this guy. 0 times this guy is 0. What does that tell me? One factor 6x is 0. The other factor x squared plus 75 is 0. Well, this part cannot happen because x squared is positive. At worst it's 0. Add 75. So the x squared plus 75 is well above 0. It's more than 0. Cannot be equal 0. So this part cannot happen. Only this part can happen. So divide both sides by 6 to give me x equals 0 as the only solution. So that is the only solution to second derivative equals 0. When a second derivative undefined, the same story, denominator 0 gives me plus 5, negative 5. But remember, these are not in my domain. So they won't give me inflection points. This one might. Okay. Now let's study concavity. 3 intervals, negative infinity to negative 5. I chose a test point. Negative 5 to 0. I chose a test point. 0 to 5. I chose a test point 1. 5 to infinity. I chose a test point 6. So negative 6, negative 1, 1 and 6. So these are my test points which I will plug in to detect my sign. I plug in x equals negative 6. So that gives me a negative. Negative 6 squared is positive plus 75. That's positive. Negative 6 squared is 36. Minus 25, positive. Positive power 3. So that's a positive. Overall, because of that one minus, I have a negative sign. If second derivative is negative, my f is concave down. So what happens here? I am concave down. All right. Now, second interval. I took negative 1. Negative 1, replace x by negative 1. That gives me a negative sign. Negative 1 squared. Positive 1 plus 75. That's a positive. Negative 1 squared. 1 minus 25. That's a negative, which appears 3 times because power is 3. So how many negatives in all? 1 above, 3 below. 4 negatives makes it a positive. Concave up. All right. Third one, 0 to 5. Choose a test point. I have taken 1. 6 times 1. That should be a positive. Typo. Yeah. Upstairs, that's a positive. 1 squared is positive plus 75 positive. So I have positive, positive upstairs. 1 minus 25, negative, 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 negative. 3 negatives in all. That's a negative, so it's concave down. The third interval, I am concave, concave down here. All right. The last interval, 5 to infinity, I've taken 6. 6 times 6, whatever, positive. 6 squared plus 75, 36 plus 75, positive. 36 minus 25, positive, 3 times. Everything is positive. So, concave up. All right. So, that's what we have in this number line. Okay. So, notice 0 gives me an inflection point because concavity changed around it. Negative 5 could have given me inflection point, but this is not in our domain. Likewise, 5 could have given me inflection point, but it is not in our domain. Okay, so 0 is the only point which gives me inflection point. So plug that 0 in my f being my original function, the question. That's where you plug in to find your y coordinates, mind you. Okay, so I plug in x equals 0 to get 0 upstairs. So 0 eventually. Point of inflection is 0, 0. Okay. So this completes all the details for sketching the graph. In my next video, I will sketch the graph with you. Okay.